This morning, Elon Musk announcing that for the first time, his company Neuralink has implanted a brain chip in a human. Musk saying the person is recovering well. Initial results show promising neuron spike detection. Neuralink's goal is to help paralysis patients communicate by connecting their brain to a computer.
The device is designed to interpret your neural activity so you can operate a computer or a smartphone by simply thinking.
People paralyzed from stroke, from traumatic brain injury, or a spinal cord injury could see the benefits.
This would be a major game changer if it were to be proven to be safe and effective.
The FDA approved Neuralink for human tests last May after years of testing on animals.
Here's one electrode on one thread that when we stimulate causes a flexion movement of the leg.
The company demonstrated the ability of its implants to stimulate movement.
As you can see, Pager is amazingly good at mind palm.
Allowing a monkey to play a video game.
And what better reward for a monkey than a banana?
Musk says the first human users will be people who've lost the use of their limbs. But speaking about the long term, he said, imagine if Stephen Hawking could communicate faster than a speed typist or auctioneer. That is the goal.
I really do think that in my lifetime as a physician, I'll be able to use this type of technology to help my patients, and I cannot wait for that day to come.
Neuralink's engineers aren't the only ones turning science fiction into reality. Researchers elsewhere helped this man, paralyzed in an accident, walk again thanks to implants in his brain and spine. And in August, this woman who had lost her voice to paralysis was able to have a conversation with her husband again thanks to a mind-controlled avatar.
Do not make me laugh.
Experts warn much more testing and research is needed before any kind of widespread use of these devices.
Hi everyone, George Stephanopoulos here. Thanks for checking out the ABC News YouTube channel. If you'd like to get more videos, show highlights, and watch live event coverage, click on the right over here to subscribe to our channel, and don't forget to download the ABC News app for breaking news alerts. Thanks for watching.
Elon Musk's Neuralink faces hurdles. First human brain chip encounters issues. Neuralink, led by Elon Musk, encountered a setback with its first human brain chip implant when threads monitoring neurons became dislodged, the company disclosed. The malfunction began in late February, and it remains uncertain why the threads retracted or if they present a safety risk. Despite the issue, Neuralink has managed to mitigate data loss by adjusting its algorithm. The company's brain-computer interface, implanted in 29-year-old quadriplegic Nolan Darbaugh, includes 64 threads thinner than human hair, each carrying electrodes to detect brain activity. These are used to interpret brain signals into actions like moving a cursor. Arbaugh, who has been using the implant to play video games, hasn't faced immediate health issues despite the displacement. Neuralink has reported the incident to the FDA and plans further implantations. After modifying the decoding algorithm, the company improved the control accuracy, maintaining a stable performance level. There are so many questions we all have. Here are a few that may be of concern to you. Here are some thought-provoking questions that could be posed to readers after the summary. How do you feel about the potential and risks associated with brain-computer interfaces like Neuralink's implant? What implications could Neuralink's technology have for the future of medical treatments, particularly for neurological conditions? Given the issues encountered in this trial, what measures should be taken to ensure the safety and efficacy of such advanced implants in future trials? How might regulatory bodies like the FDA need to adapt to effectively oversee the rapidly advancing field of neural technology? What ethical considerations arise from the development and implementation of technology that can directly interact with human thoughts? Considering the adjustments made to the implant's algorithm to compensate for the dislodged threads, what does this say about the adaptability and resilience of such technology in dynamic real-world scenarios? What do you think? Let us know your answers in the comment area. Don't forget to like, subscribe, and follow. See you in the next video.